Hi, this is Jeline from the Honors Tutorial. Welcome to the last part of this topic, which is derivatives, the quotient rule. This is for basic calculus. So let's start. So our example now is for example number 2 already, since this is the second part and the last part of this topic. For example 2, let's say that we have here y equals 5 plus x over x raised to 6 minus 3. Okay, so let's have our solution here. But first, let us identify which is f of x and g of x. Remember, f of x is your numerator, and then g of x is your denominator. So now, the first thing that we have to do is to look for f prime. Okay, so we will be having f of x first. So that is 5 plus x. And then after that, we have to get the derivatives of f, and that is f prime of x. So 5 is a constant, so therefore automatically it will become 0, since based on our rules, the constant rule, any constant should be equal to 0. So therefore we change 5 to 0 plus x raised to 1 minus 1. Actually, there is 1 here, the numerical coefficient multiplied by the exponent, which is also 1. So therefore, we only have 1 here. So let's continue solving. F prime of x is equal to 0 plus 1 x raised to 0, because 1 minus 1 is 0. And then f prime of x is equal to, let's eliminate 0 and then let's have 1 here, times 1. 1 times 1, it is because when a term, a variable or a number is raised to 0, then it is equal to 1. So f prime of x is equal to 1. So this is the value of the derivatives of f of x. Next, we also have here g prime of x. So we have here, let's write g first. G of x is equal to x raised to 6 minus 3. Let's get the derivatives of g of x. So we have here g prime of x is equal to 6, the exponent, x raised to 6 minus 1. And then since negative 3 is a constant, we can just remove it, eliminate it, because negative 3 is equal to 0. Let's continue solving. G prime of x is equal to 6x raised to 6 minus 1, that's 5. So therefore, as you can see in here, the value of g prime of x is 6x raised to 5. Next. Now, let's have the third part of our solution. For the third part of the solution, we will be having the pattern that we have studied on the part 1 of this video. So that is y prime is equal to g of x times f prime of x minus f of x times g prime of x over the quantity of g of x raised to 2. Okay. So we have here y prime is equal to g of x, that is equal to the quantity of x raised to 6 minus 3 times f prime of x, that is 1, minus f of x. F of x is 5 plus x times g prime of x, that is 6x raised to 5. And then over the quantity of g of x raised to 2. So g of x is the quantity of x raised to 6 minus 3 raised to 2. Let's continue solving. So we have here y prime is equal to x raised to 6 times 1. So that is x raised to 6. Then negative 3 times 1 is negative 3. Let's put it in a parenthesis first. Next, we have here 5 times 6x raised to 5, and that is 30x raised to 5, and x times 6x raised to 5, and that is plus 6x raised to 6. It is because we should add the numbers of the exponents. So we have here 1 plus 5, that is 6. Next, you have to copy the denominator. So for the denominator, we have here the quantity of x raised to 6 minus 3 squared. And then, let's write y prime is equal to x raised to 6 minus 3. We are now removing the parentheses. But for the second given, always remember that you have to change all of the signs of the second given. So positive 30x raised to 5 will become negative 30x raised to 5. And positive 6x raised to 6 will become negative 6x raised to 6 over the quantity of x raised to 6 minus 3 raised to 2. Okay, let's continue solving. Let me just use this part. It's possible. So that is y prime, again, that is y prime is equal to x raised to 6 minus 6x raised to 6. So that is equal to negative 5x raised to 6. How about negative 30x raised to 5? We don't have any partner for it, so just copy. And then for negative 3, just copy also because we don't have any partner for it. And then copy the denominator, that is the quantity of x raised to 6 minus 3 squared. So this is the answer for the first derivative of the given. So if you have questions, clarifications, or inquiries about the topic, just message us via Messenger, the Honors Tutorial. Thank you for today and God bless.